We're in 6th grade. Welcome to lesson 40 on math. We got Power Up G here, practicing adding, subtracting, multiplying, and dividing fractions. Reading across the rows, it reads like this. 1 and 1/3, 1/3, 4/9, 1. Next row, 1, 1/2, 3/16, and 3. Third row, 1 and 1/6, 1/6, 1/3, 1 and 1/3. Final row, 5/7, 1/12, 1/2, and 1 and 1/8. All right, if you found the one I got wrong, circle it, and I'll give you extra credit as your way to checking the work that I did. So I read one of those answers wrong. Your mental math would have read like this. I multiplied by 100, slides that decimal twice, gives me $18. Times 4 gives me $5. Times 6 gives me 18. Divide both those by 4 gives me 3/8. Square root is 12 and 11. Added together gives me 23. Divide by my denominator, 20 times my numerator, 2 is 40. Explain what the median is. The median is the middle number when I put them in order. So when they give me a list, guys, it's order from least to greatest, find the middle one. Start with $10, divide by 4 is $2.50, add 2/4 is $3, multiply by 3 is $9, find half that amount is $4.50, subtract 2 dimes, which is 20 cents, gives you $4.30. It says at 3 o'clock the hands of the analog clock would form a 90-degree angle. What is the measure of the angle that is formed by the hands of a clock 2 hours after 3? So what's the angle measurement of 5 o'clock? Okay, we'll just do a quick review because we had this when we were working with protractors a long time ago. Have a clock, there's 12 hours on it, forms a circle, so that's 360 degrees. I'm going to divide it by 12 hours. That goes in there 3 times, that goes in there 0, it's 30. Now they're saying what time is it at 5 o'clock, so I'm not going to, not divide. I'm going to take that answer and make it look like 5/12 times the 5 gives me 150. So it's a 150-degree angle. Remember, every hour on the clock equals 30 degrees. Okay, let's get cranking on lesson 40. Before we do that, lesson 39, yesterday you were working with proportions. Proportions are the two fractions or ratios are equal. How do I check that? I cross multiply. So numerator of one times the denominator of other should equal the numerator of the other fraction times its denominator to get that. If I'm missing a letter in that, I cross multiply and divide by the one that's left. Today, we're going to work with sums of a triangle. Many of you will hopefully remember this. We've been using this a few times this year, and then we'll talk about different angle measurements that we'll continue to build on. Starting off on page 286, it says this. A square has 4 angles that measure 90 degrees each. If we draw a segment from one vertex of the square to the opposite vertex, we have drawn a diagonal that divides the square into 2 congruent triangles. We show this in the figure below. So you got 90s in the corner and 45s by the one that's been chopped up. Segment AC divides the right angle A into 2 halves, each measuring 45 degrees. Segment AC also divides the right angle at C into 2 things, each measuring 45. Each triangle has a measure of a 90, 45, and 45, and the sum of that is 180. The 3 angles of every triangle have the measure that totals 180. We illustrate this fact with the following activity. So guys, I'm not going to take the time to do that following activity that goes on the next page and a half, but every triangle adds together. They're showing you the pieces to equal 180. So if I'm in my yellow folder, guys, you can see angles of a triangle add up to 180 degrees. It needs to be memorized. Way at the end of the year, we'll teach you how you can figure out every shape, what their angles measure up to. It's a math formula that we have for that. Okay, so number 1, they'll show you how to work these things. It says, find the measure of angle A in ABC. Guys, they're always going to give you 2 measurements and have you find the third one. So we're looking for angle A, and you're going to say 2 measurements, or they only gave us 1. Well, they gave you the 30, guys, but they also gave you the right angle, and you know that right angles equal 90 degrees, so it's just a simple math problem. I just do 30 plus 90 equals 120. Take that answer, minus it from my 180, and that tells me my other thing is 60 degrees. Okay, so add it together, subtract from 180, and you got it, example 1. Now we'll start talking about the second part of the lesson, which is the angle pairs. 2 intersecting lines form 4 angles. We have labeled these 4 angles as angles 1, 2, 3, and 4 for easy reference. Angles 1 and 2 are what are called adjacent angles. They share a common side. Notice that together they form a straight angle. A straight angle measures 180 degrees, so the sum of measure 1 and 2 is 180 degrees. Two angles whose sum is 180 degrees are called supplementary angles. We say that 1 is a supplement of 2 and 2 is a supplement of 1. So back into your yellow folder, guys, it has supplementary angles, two angles whose sum is, once again, 180 degrees. Notice that angles 1 and 4 are supplementary angles. If we know that the measure 1 is 60, then we can calculate measure 2 as 120 because 60 plus 120 equals 180 degrees. And we know that measure of angle 4 is also 120, so that 2 and 4 have the same measure. Another pair of supplementary angles are 2 and 3. And a fourth pair of supplementary angles is 3 and 4. So anything that forms a straight line there, guys. Where was I? 3 and 4. Knowing that 2 and 4 measure 120, we can calculate that measure 3 is back to number 60. So 1 and 3 are the same measures. Angle 1 and 3 are not adjacent angles. They're called vertical angles. Likewise, 2 and 4 are vertical angles. Vertical angles are a pair of non-adjacent angles formed by a pair of intersecting lines. Vertical angles have the same measurement. So supplementary adds up to 180. Vertical, diagonally through each other, are equal to each other, guys. Two angles whose measures equal 90 are called complementary. In the triangle below, A and B are complementary angles because the sum of their angles equals 90 degrees. So A is a complement of B and B is a complement of A. So guys, into your notes you have the last one there. Complementary angles add up to 90 degrees. You got to keep that straight. Supplementary, 180. Complementary, 90. We're going to use them a lot. Get used to that drawing. For example 2, you're going to get it from now to the end of the year, finding missing measurements in an angle that has a straight line added to a triangle. It says find the measures of all those angles. Okay, so I'll get it drawn for you here, and it looks like this. I have my triangle, and then they're going to cross those lines through it. So they gave me a right angle, which I know is 90 degrees. They also gave me 50 degrees. So step 1, 90 plus 50 equals 140. You subtract it from 180 like we did for example 1, and that tells me I have 40 degrees left. So this guy down here is 40 degrees. Now this guy forms a straight line, guys. So I now take 180 minus 4. Sorry, let me get on the computer there and turn my screen a little bit so you can see a little better. Now I take this 180 minus this 40 and get back to the 140. So this guy is 140. Now I do 140 minus 180 again, and this guy is 40. Okay, now we could have said this guy and this guy are 40 because of vertical angles. I said this guy plus this guy equals 180 because of supplementary angles. So working these three angles, guys, we'll do it all the time. Add, triangle, straight line, supplementary angles, straight line, supplementary angles. Okay, example 3 says figure ABCD is a parallelogram. Segment BD divides the parallelogram into two congruent triangles. Angle C to B to D measures 40. Which other angle also measures 40? So that would look like this, guys. You got your parallelogram, and then they chopped this and they said this is 40, this is 60. Okay, now inside this triangle, I would add that together and say that's 80 degrees because it adds up to 180. Okay, now what they're doing is, guys, they're trying to give you vertical angles backwards, and what they're saying, if this is congruent, then opposite sides are equal. This guy over here would be this 80, this guy over here would be this 40, and this guy up here would be 60, because they would spin on top of each other. So they're just teaching you how to spin an angle and get the measurements for it. Okay, so the question is, which other angle measures 40 degrees? That is A to D to down here B. That angle right there. Okay, guys, that's it for the examples with it. You might want to practice on IXL. You might want to look through the letters with that. There's a lot of key information. Example 2 is what you're going to see the rest of the year as we work with complementary, supplementary, and some of the angles from lesson 40. All right, I'll see you for the word problems. All right, 6th grade, here we cruise with lesson 40. The first one we're doing is number 2. It says John ran 4 laps in track in 6 minutes 20 seconds. How many seconds did it take John to run 4 laps? So I know there's 60 seconds in a minute. I know I got 6 minutes, so I multiply. Gives me 360. He also had the 20 seconds on top of that, so it's 380 seconds. That's part A. B says what was his average? So I take my answer from A of 380 and divide it by the 4 laps. Okay, that goes in there 9 times. That's 36. Subtract 20, that's 5. He's averaging 95 seconds a lap. Not very good if you're a trackster and you're in 7th, 8th, 9th, 10th grades like that. You got to get laps faster than that, but that's beside the point. Number 4, at sea level, water boils at 212 degrees. For every 550 feet above sea level, the boiling point of water decreases by about 1 degree. At 5,500 feet above sea level, water boils at 202 degrees Fahrenheit. How many degrees hotter is the boiling temperature at sea level than at 5,000? Well, okay, boiling point at the one is 212. Boiling point at the other is 202. I subtract and I got 10 degrees. B, at the summit of Puncak Jaya, the highest mountain in Indonesia, water boils at 183 degrees. About how many feet above sea level is the summit? So it normally boils at 212. They get it to boil at 183. So the first thing I'm going to do is I'm going to figure out how many degrees that is. So that's 20. I got a 12 there. That's 9. 20 minus 18 is 2. So it's 29 degrees difference, and I know every degree is worth 550 feet. So I take 550 times 29. Gives me a 0, gives me a 45, carry the 4, gives me a 45, gives me a 49. Add a 0. 2 times 0 is 0, 2 times 5 is 10, 2 times 5 is 10, plus 1 is 11. I add 0, 5, 9, 5, 1. Okay, so great answer here. The only thing, if you wanted, it said the question was about how many feet above sea level. So this is choice 1. Choice 2, I would round that to 1,600. Okay, either answer works, guys, depending on your definition of the word about. Answer A, one of those two for answer B. Don't forget a label there, guys, for number 4. Number 5 says the length of the rectangle to the right is twice its width. What is the perimeter? So the length is twice this. So what number times 2 equals 70? So if I'm going the backwards, I divide. That goes in there 35 times. So that tells you this is 35. Now I take 70 plus 35. Gives me 105 times 2. Gives me 210. We're working with millimeters, so the perimeter is 210 millimeters. What's the area? That's multiplication, guys. So I'm going to do 35 times 70. Put the 0 off to the side to get it done in one step. Gives me 35. Carry gives me 21 plus 3 is 24. That one's millimeters squared. Number 10. The coordinates of the 3 vertices of a triangle are that, and that. My job is to find the area. Okay, let's plot it. The first one's at negative 2, up 1, 2, 3, 4, 5. So negative 2, 5. The next one's at 4, 1, 2, 3, 4, and 0. The last one's at negative 2 and 0. So they gave me a right triangle, guys. I'm just going to count. 1, 2, 3, 4, 5, 6. So from negative 2 to positive 4 is 6. I'm going to count up from 0 up to 5. That's 5. 6 times 5. 6 times 5 is 30. Divide by 2 is 15. Or you could have cut that in half first. Got 3 times 5, 15. I don't know what we're working with, so we call it square units. Notice how they're taking the lesson of area of a triangle and adding it to coordinate planes. Number 12. Find the measure of each angle in that beautiful drawing. They gave me 70. They gave me 75. Now they're going to try to work this thing in order. The first thing I want is ACB. So I want this number first. I do 70 plus 75 is 145. I subtract 145 from 180. Gives me 35. So letter A is 35 degrees. B says, what's this next one that goes from here to here? Guys, that's always what you get when you add them together. So that guy out there goes to 145 because they're supplement. Then the last one they want is back to this one down here. That's the same as this one, so back to 35. So as we start out here, guys, lots of times it'll be same, and the supplement of it. Okay, number 13. Angle ACD is supplementary to ACB. Name another angle supplementary to ACB. So they gave you ACB, this one, and they're asking me, hey, this one goes to ACD. So this one goes from here to here. Good. Now they said name another one that goes with this guy. Well, guys, they went left. You got to stay on the right. So they want this guy down here. So let's find the letters. B to the middle, C, down to the bottom, E. So for number 13, you want angle B, C, E. Number 14, which property illustrated by this equation? You have A, guys, 10 over 10 equals 1. That's called the identity property. Look for that multiplying by 1. Find the quotient of this one. So, guys, that's just a division problem now. Has really absolutely nothing to do with the top part, except they're saying, can you solve it now? So that goes in there 2, that's 10, that's 20, goes in there 4, 14B. Turn your page, flipping your answer key over, cruising on. Number 17. We got proportions from yesterday. I'm going to have 9/12 equals 15 something. I'm going to reduce this by dividing by 3, guys. That reduces to 3/4. Now I look, how did I get from 3 to 15 times 5? What's 4 times 5? M equals 20. Number 20, 1 meter minus 12 centimeters equals how many meters? So guys, I have 1.2. The job is to switch my 12 centimeters to meters. That's left twice, so it becomes 0.12 meters. So cross out, add a 0. That becomes 1, that becomes 10. That's an 8, that's a 0. Decimal point straight down, 1. 1.08 meters. Do not go so fast that you miss that they're different measurements there. Number 21, parentheses next to each other means multiply. So I'm taking 15 times 5. That gives me a 25. Carry it, that gives me a 7. Now it wasn't that, it was 0.0. So 1, 2, 3, 4. 1, 2, 3, 4, decimal point 0. So I have 75 10,000ths. Make sure you're counting decimal points. Number 24, I start with 4 minus 1 and 25/100ths. Add a decimal point and 2 zeros is 3, 10, 9, 10, 5, 7, 2, and 75/100ths. My job is to now take that and subtract it from 5.6 minus 2.75, add a 0. 6 becomes a 5, 10, that's a 5. 5 becomes a 4, 15, that's an 8, decimal point 2. And I got 2 and 85/100ths. Moving over to 25, I start with addition. 3.14 minus 1.2 is 434. Now I'm going to subtract that from 5.00. That becomes a 4, 10, 9, 10, 6, 6.0. So I got 66/100ths. 27, you got a division one. I have 7 divided by 5 and 5, 6. Make them improper. 7 over 1 divided by, multiply 30 plus is 35 over 6. Rules for division stays the same. Change the multiplication, flips over. Divide by 7, gone. Divide by 7, 5 gives me 6 over 5. Divide goes in there 1 time and I have 1 left over. 1 1/5. 29, I have 4 2/5 minus 1 3/4. Common denominators would be 20. So multiplying this by 4 over 4 gives me 8. Multiply this by 5 over 5 gives me 15. I'm going to cross out the 4, make it a 3. That brings over 20. I add it to the 8, I have 28. I now subtract 28 minus 15 gives me 13. The 20 stay the same. 3 minus 1 is 2. And I have 2 and 13/20. And last but not least, number 30. The perimeter of the square room is 15.84 meters. Estimate the area of the room. How did you make your estimate? Okay, so the perimeter, I estimated it at 16. I divide by 4 because there's 4 sides on a square, it gives me 4. So I have a square room that is 4 by 4. I multiply, it is 16 square meters. Okay, how did you get your estimate? Well, I rounded and I divided, and if you show your work, that explains every answer you ever need, guys. Okay, it was a great lesson today. Make sure you keep that triangle with the lines coming off it.